Hello everyone. In this video, we are going to discuss theory of equations, which is related to quadratic equations and expressions. So let's first see the definition. What is the definition of a polynomial equation? So from there, we will start the theory of equation. Definition for this: an equation of the form. An equation of the form. An equation of the form f of x is equal to p naught x power n plus p1 x power n minus 1 plus p2 x power n minus 2 plus so on plus pn is equal to 0, where p naught not equal to 0, because if p naught is becomes 0, it will not be called a nth power equation. So p naught equal to 0 is called an nth degree polynomial equation. An nth degree polynomial equation. So here simply we can say examples like ax power 4 plus bx cube plus cx square plus dx plus e is equal to 0. So this is the highest degree term as 4. We can call it as biquadratic equation. So another example like x cube minus 3x square plus 3x minus 1 is equal to 0. Cubic equation, because highest degree is 3. So this is the definition for a polynomial equation. So here in the theory of equations, we can read power 2, power 3, power 4, power 5 up to power 6 equations we can see. So in that, let's see first for a quadratic equation. So how can we take relation between the roots and the coefficients? So you know the general form of a quadratic equation: ax square plus bx plus c is equal to 0, provided condition a not equal to 0. So if I'll assume the alpha comma beta are the roots of this equation, so we can take sum of the roots. Is alpha plus beta is equal to minus b by a, and product of roots we can take c by a. So how we will get this? Let's see. So we are discussed here alpha comma beta are the roots of the equation. That means alpha and beta are nothing but x values, right? So that means x minus alpha comma x minus beta are the factors of this quadratic equation. So these are the factors. That means that if you multiply this x minus alpha and x minus beta, so we will get this quadratic equation. So that's why we will take this like ax square plus bx plus c is nothing but some product of x minus alpha into x minus beta. But we cannot say the x square quotient is always 1. So there will be a constant a which will be multiplied, whether it will be 1 or other than the 1, but not 0. So this here take the a common. So x square plus b by a x plus c by a is equal to a times of, you will multiply this one, you get x square minus alpha plus beta into x plus alpha beta. So just we'll remove the a on both sides, and by comparing on both sides, so what we will get? So first let's we compare the quotient of x. So what is the quotient of x on right hand side? Minus of alpha plus beta. So left hand side is b by a. So that means alpha plus beta is equal to minus b by a. This is the relation between the coefficients. One relation between roots roots and coefficients of the given quadratic equation. So let's see, compare the constant. If you will compare the constant, right hand side you have alpha beta, left hand side you have c by a. So this is product of roots. This is product of roots. This is sum of roots. So this is the way how we will get the relation between roots, roots and relation between roots and coefficients, of a quadratic equation, So let's see what is the relation between roots and coefficients for a cubic equation. So relation between roots and coefficients for a cubic equation. Let's see how to take this. So general form of a cubic equation is, we know ax cube plus bx square plus cx plus d is equal to 0, where provided a not equal to 0. Let us assume alpha, beta, gamma are the roots of this cubic equation. Then sum of roots. So here onwards, every time we cannot write like sum of roots, sum of product of two roots at a time like that. So we will leave it like S1. Sum of roots is S1. So S1 is alpha plus beta plus gamma is equal to minus b by a, and sum of product of two roots at a time, product of two roots at a time is equal to c by a, and product of roots here, this let's we take S2, so continuously like S3. So product of roots, let's we take S3, so that is minus d by a. So here also the proof for this one you will get in the same way, like a into x cube plus b into x square plus cx plus d can be written as a times of x minus alpha into x minus beta into x minus gamma. So take the a common here, so you'll get x cube plus b by a x square plus c by a x plus d, which is a into the multiplication of 3, you will get x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. So when you will compare on both sides, S1 you will get alpha plus beta plus gamma is equal to minus b by a. S2 you will get alpha beta plus beta gamma plus gamma alpha is equal to c by a. So alpha beta gamma you will get minus d by a. So this is the way how we will get the relation here between the roots and coefficients. If you go for biquadratic, so what is the biquadratic here? What is the biquadratic equation? So if you'll see biquadratic equation in this, so it is in the form of like ax power 4 plus bx cube plus cx square plus dx plus e is equal to 0, right? So for this one, if you'll assume alpha, beta, gamma and delta are the roots, S1 we can take alpha plus beta plus gamma plus delta, which is minus b by a, and S2 will be alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta is equal to c by a. So S3 is alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. This will be minus d by a, and S4 is alpha beta gamma delta is equal to e by a. So like this, So we can take for any power. If you look at for nth power, so if you look at for nth power, so what is the nth power polynomial equation here? Nth power polynomial equation. Nth power polynomial equation, if you look at, so how it will be is, some f of x is equal to p naught x power n plus p1 x power n minus 1 plus p2 x power n minus 2 plus p3 x power n minus 3 plus so on, plus pn is a constant which is equal to 0 provided p naught is equal to 0. So if I'll assume alpha 1, alpha 2, alpha 3 and so on, alpha n are the roots, are the roots of this, so then we will get S1 as nothing but summation of alpha 1 means alpha 1 plus alpha 2 plus like that minus p1 by p naught. So S2 is sum of product of two roots at a time, that is S2 p2 by p naught, and if you take the S3, that is the sum of product of three roots at a time, we can take summation of alpha 1, alpha 2, alpha 3, which is minus p3 by p naught. So on. If you want the product of roots at last, product of roots, so we can take that one as Sn. Sn will be, we don't know whether it will end with minus or plus 2 minus 1 whole power n. So p n by p naught is the product of roots of nth degree polynomial equation. So this is the way how we will take the relation between the roots and coefficients, so of different power polynomial equations. So here one more thing what we can discuss here is, if the roots are in AP or GP or HP, so how to take that roots? So let's see, just for a cubic equation, I'll discuss here. For a cubic equation, so how to take, if roots are in GP, so if roots are in AP, let's take first. If roots are in AP, so that roots can be taken like alpha minus beta, alpha, alpha plus beta. This is the way I will assume the three roots and we will continue solving the problem. Second point is, if roots are in GP, so how can we take is alpha by beta, alpha, alpha beta we should take. If roots are in HP, so how can we take 1 by alpha minus beta, alpha, 1 by alpha, 1 by alpha plus beta, and we will solve the problem. So for a biquadratic equation, so how can we take the roots? For a biquadratic equation, how can we take the roots? So for a biquadratic equation, we should take the roots as like alpha minus 3 beta, alpha minus beta, alpha plus beta, alpha plus 3 beta. Means here we are taking the common difference as a 2. Okay, so in AP, we can take like this. In GP means 1 alpha by beta cube, alpha by beta, alpha beta, alpha beta cube. So in HP, we can take like 1 by alpha minus 3 beta, 1 by alpha minus beta, 1 by alpha plus beta, 1 by alpha plus 3 beta. So like this we will take and we will continue solving the problems. So is there any direct condition? Not like this procedure. So if we have any direct condition, means yes, we have direct conditions when roots are in AP, roots are in GP, roots are in HP. So in this we will discuss one or two how we will get that condition. So remaining we will take the points. If you'll see the condition for that the roots are in AP, the condition that the roots of ax cube plus bx square plus cx plus d is equal to 0 are in AP. So let's see. Direct shortcut we will try to find out. The condition for this one is we have like 2bq plus 27a square d is equal to 9abc. So this is the direct condition. Let's see how we will get. So we'll use the method to solve this. So what is the method is when for a cubic equation roots are in AP, just now we have discussed that roots we have to assume like alpha minus beta comma alpha plus beta. So let's think these are the roots of ax cube plus bx square plus cx plus d is equal to 0. Then s1 is what? Sum of roots. That is sum of roots. So how can we take the sum of roots here? Alpha minus beta plus alpha plus beta. This is equal to minus b by a. So minus beta plus beta cancel. So we'll get 3 alpha is equal to minus b by a. So from here we'll get alpha is equal to minus b by 3a. So let's we take this is the equation 1. So let's we take this is the equation 1. Next, sum of product of two roots at a time, that is S2. So alpha minus beta into alpha plus alpha plus beta plus alpha plus beta into alpha minus beta. So this is equal to, we can take C by A. So when we'll simplify this one, we get alpha square minus alpha beta plus alpha square plus alpha beta plus alpha square minus beta square is equal to C by A. So minus alpha beta plus alpha beta will cancel here. So 3 alpha square minus beta square is equal to C by A. So let's see, this is the equation 2. So next, if you'll see S3, product of roots, that is alpha minus beta into alpha plus beta, that is equal to minus d by A. So what we'll get from here, alpha square minus beta square into alpha is equal to minus d by A. So which is alpha square minus beta square into minus b by 3a is equal to minus d by a. So from here we'll get alpha square minus beta square is equal to 3d by b. Let it be equation 3. So if we'll solve this, we'll substitute the beta square value here. Just first we'll do minus 3 we will do. So we'll do the 2 minus 3, equation 2 minus equation 3 we'll do. So what is the equation 2 is 3 alpha square minus beta square is equal to C by A. So alpha square minus beta square is equal to 3d by b. So if we'll subtract these two, so we'll get 2 alpha square is equal to C by A minus 3d by b. So what is this we'll get here is next 2 alpha square. Here alpha value we will substitute. We'll substitute the alpha value. So if we'll substitute the alpha value, 2 into minus b by 3a whole square plus 3d by b is equal to C by A. So this is equal to, we'll get 2b square by 9a square, 2b square by 9a square. So 2b square by 9a square. So we'll get 2b square by 9a square plus 3d by b is equal to C by A. So if we simplify this one, we'll get 2b cube plus 27a square d is equal to 9abc. 9abc. So this is the direct condition to the roots of a cubic equation are in AP. So we'll see one more thing, that if roots of cubic equation in GP, roots are cubic equation in GP, the condition that the roots of ax cube plus bx square plus cx plus d is equal to 0 are in GP. So that we will see here. So what we should take here when roots are in GP, alpha by beta, alpha, alpha beta. So these are the roots we will assume. Roots of ax cube plus bx square plus cx plus d is equal to 0. Here we'll take sum of roots. Sum of roots will be alpha by beta plus alpha beta is equal to minus b by a. So from here, if I'll take the alpha common, 1 by beta plus 1 plus beta is equal to minus b by a. I'll get, let it be equation 1. So next equation 2, from the S2 we will get sum of product of two roots at a time. Alpha by beta into alpha plus alpha into alpha beta plus alpha beta into alpha by beta is equal to c by a. So here beta and beta gets cancelled. So let's take the alpha square common. You'll get 1 by beta plus 1 plus beta is equal to c by a. Let it be equation 2. So do equation 2 by equation 1. So we'll get alpha square into 1 by beta plus 1 plus beta is equal to c by a. So that is equal to, divided by alpha into 1 by beta plus 1 plus beta, here divided by minus b by a. So a and cancel and this is cancel, 1 alpha. So alpha value will get minus c by b. Alpha value will get minus c by b. So next we will take S3. So S3 is product of roots, that is alpha by beta into alpha plus b, alpha beta is equal to minus d by a. If beta cancel, you'll get alpha cube is equal to minus d by a. So from here, we will substitute the alpha value as minus c by b in this result. So we'll get minus c by b whole cube is equal to minus d by a. So if you simplify, you'll get ac cube is equal to b cube d. So this is the condition for a cubic equation. Roots are in GP. Roots are in GP. So for roots are in HP. For roots are in HP. So what we have the condition is for roots of a cubic equation are in HP. Are in HP. We have 2c cube plus 27 AD square is equal to 9BCD. So this is the condition when the roots are in HP. So let's see one problem based on this. Let's see the problem. So problem is, if the roots of the equation, if the roots of the equation 4x cube minus 12x square plus 11x plus k is equal to 0 are in AP, find k. So this is the question. So what is the condition? Just now we discussed here when roots are in AP. So if roots are in AP, for a cubic equation, we have condition 2b cube plus 27a square d is equal to 9abc. So this is the condition for the roots are in AP. So this is the given equation, 4x cube minus 12x square plus 11x plus k is equal to 0. When I will compare this with ax cube plus bx square plus cx plus d is equal to 0. So I'll get a value is 4, b value is minus 12, c value is 11, d value is k. So this is 2 into minus 12 cube plus 27 into 4 square into k is equal to 9 into 4abc, 4 into minus 12 into 11. So if we'll calculate this, so what we'll get? So 2 into minus 12 whole cube is minus 3456 plus 432 into k is equal to minus 4752. So from here, 432 into k is equal to minus 4752 plus 3456. So which is 432 into k is equal to minus 1296. So k is equal to minus 3. So this is the way how we can use that conditions. So this is one small example for that concept clarity. Next part of the theory of equations. So what is the next is the equation of lowest degree with rational coefficients. So what is the next point is the equation of lowest degree. The equation of lowest degree. The equation of lowest degree with rational coefficients. With rational coefficients. Having a root, root a plus root b is. So what is that direct formula? Let's we see. See, if root a plus root b is one root, so we can say automatically root a minus root b is the another root, and minus root a plus root b is the another root, and minus root a minus root b is the another root. Means these are nothing but x values. So when we will take into factors and multiply all, so we'll get the equation of lowest degree with rational coefficient. So let's see that x minus root a plus root b into x minus root a minus root b into x minus root a plus root b into x minus root a minus root b is equal to 0. So if you'll remove the inside brackets here, so we'll get x minus root a minus root b, x minus root a plus root b, x plus root a minus root b, x plus root a plus root b is equal to 0. So that is equal to, see here, so we can take this as the pairs. We can take this as the pairs. X minus root a, x minus root a, x plus root a, and x plus root a. So we'll keep the bar bracket for this one. So then it will become like a minus b into a plus b form. So what is the a minus b into a plus b? So it is a square minus b square. So let's we apply this here. So we'll get x minus root a whole square minus root b whole square into x plus root a whole square minus root b whole square is equal to 0. Is equal to 0. So this is equal to x square plus a minus 2 root ax. Here square and square root cancel, so we will get minus b. X square plus a plus 2 root ax. So square and square root gets cancelled, minus b is equal to 0. So if you look at this one, so x square plus a minus b. So this minus b I'm taking front. So minus 2 root ax into x square plus a minus b plus 2 root ax is equal to 0. So again, this total as one term and this is one term. Total as one term and this one term. So again, it will be converted into a minus b into a plus b whole square. I mean a minus b into a plus b, that is a square minus b square. So x square plus a minus b whole square minus 2 root a x whole square is equal to 0. So this is, if you'll simplify again, so here for this we can apply a plus b plus c whole square form, that is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So this is equal to x power 4 plus a square plus b square plus 2ax square minus 2ab minus 2bx square minus, here it is 4ax square is equal to 0. So x power 4, so here plus 2ax square and minus 4ax square, so it will become minus 2ax square, and next we have here minus 2bx square. Next remaining all are a square plus b square minus 2ab we have. So from here, if I take x power 4 and minus 2x square common, it will become minus 2 times of a minus b into x square, plus this is a minus b whole square is equal to 0. So this is the lowest degree equation with roots are root a plus root b form with rational coefficients. So this is the direct formula for this particular topic. So let's see conceptual clarity problem. So what is the problem is, just we'll see the equation of lowest degree with rational coefficients. The equation of lowest degree with rational coefficients having a root 3 plus root 2 is. So this is our question now. So this is the formula, that is x power 4 minus 2 times of a minus b into x square plus a minus b whole square is equal to 0. So what they are given is root 3 plus root 2. Let's compare this with root a plus root b. So we will get a is equal to 3, b is equal to 2. A is equal to 3, b is equal to 2. So we'll substitute here x power 4. This will be plus. We will take the minus common. So x power 4 minus 2 times of 3 plus 2 x square plus 3 minus 2 whole square is equal to 0. So x power 4 minus 10x square plus 1 is equal to 0. So this is the way directly how can we solve shortcut. So let's see in place of root 3 plus root 2, if we have root 5 plus root 2. So what is the equation of lowest degree terms? Here a is equal to 3, sorry, a is equal to 5, b is equal to 2. So what we have formula, x power 4 minus 2 times of a plus b into x square plus a minus b whole square is equal to 0. So x power 4 minus 2 times of 5 plus 2 into x square plus 5 minus 2 whole square is equal to 0. So what you will get here, x power 4 minus 14x square plus 9 is equal to 0. So this is the equation for this particular question. So hope you understand the concept and the problem how to solve based on this. So in the similar way, we have one more shortcut formula. Just we'll see directly. I'll write. I'll not tell the proof because proof is same like the previous one how we take. The equation of lowest degree. The equation of lowest degree with rational coefficients having a root root a plus I root b is x power 4 minus 2 times of a minus b into x square plus a plus b whole square is equal to 0. So the difference between the previous formula and this formula, if you'll observe, so previous formula is x power 4 minus 2 times of a plus b into x square plus a minus b whole square is equal to 0. So here you got plus, here you got minus, here you got minus, opposite plus. So please remember these two to solve the problems based on this. You'll get directly answer, nothing but shortcuts. So this is the concept in this video. So in the next video, we will discuss the remaining concepts of theory of equations along with the problems. And I'm going to do the daily practice problems also soon after completing one chapter. So I'm going to solve the different kind of problems and I'll make that video. So for more videos, please follow my channel, please subscribe my channel, and please support to me to do the more good videos for IIT as well as for the state board and CBSE. Thank you all. Thank you.